So the AI in GraphAI stands essentially for artificial intelligence methods. The GraphAI portfolio is a set of solutions, of several different solutions for several different needs. So that means essentially that the different tools use different AI algorithms. The GraphAI library essentially covers tools which range from supporting activities for creating knowledge graphs to exploring or exploiting knowledge graphs, meaning to actually use the data to reveal or hidden knowledge within the knowledge graph to answer particular questions. The algorithms in GraphAI are essentially a set of solutions for different needs. For example, we have open knowledge graph extraction, which is a tool which helps to get from unstructured data a knowledge graph. The tool essentially exploits the text by extracting relations and entities automatically, which in turn can be used to build or construct a knowledge graph. Another solution which we have and which is part of our GraphAI portfolio is KBlrn, knowledge-based learning. KBlrn exploits knowledge graphs and essentially tries to find within the knowledge graph hidden information or patterns to answer information of interest. Of course, when it comes to AI, explainability is always an important function, and as such we also have a solution for that, which is called gradient rollback. Gradient rollback can be used together with KBlrn to understand how the algorithm, so KBlrn, came up with a particular answer. Compared to classical machine learning approaches, GraphAI essentially has its advantages in using the knowledge graph. Classical machine learning approaches usually operate on tabular data. Tabular data have several disadvantages, like for example linking information across records is not easily possible. On the other side, missing values is something which is totally normal in reality, but at the same time, in tabular data combined with classical machine learning approaches, this is always a challenge. So far we have applied GraphAI already in various different domains. In the healthcare domain, in the insurance domain, but also in the public safety domain. The domains are very different, and as such are the problems which we have to address with GraphAI. So for example, in the healthcare domain we focus on patient stratification, where in the public safety domain we focus on incident detection. The point is, when we talk with our partners in these different domains, the problems which they might have could be something where we actually don't have a solution. So here, we essentially have our core researchers and our applied researchers at NEC Laboratories Europe. If we have a problem which really is something which we have to work on from scratch, we feed this problem back to our core researchers, which develop new methods and solutions, and at some point this is shift over or hand over to applied researchers, which bring it to the next level. Considering a hospital scenario, here we have several different patients with different diseases and with different needs. At the same time, due to the different characteristics of the people, we don't have to record all necessary vital parameters of these people. For instance, for some we need the blood pressure level, for others we don't. So missing values is something which just is normal in reality. However, classical machine learning approaches have a problem with such scenarios. And here, GraphAI essentially has its advantage, because here we can apply novel strategies due to the graph structure to essentially fill the gaps, so the missing values, with our AI solution. The digital government domain essentially consists of several different subtopics. So on one side we have the public safety domain covering things like the control room and the fire department. On the other side we have the public service domain covering tax declaration, but also resource management like water, electricity and waste. With GraphAI we are essentially interested in supporting ongoing activities within these fields, so making things easier for humans, but at the same time to optimize resource management. Within the public safety domain, GraphAI could, for example, help in the control room. Here we have, for example, call handlers which have to handle incoming calls. It is quite normal when an incident happened that different people actually record the same incident at the same time, handled by different call handlers. So it's quite normal that within the database of the control room, the same incident occurs several times. However, this is a problem, because at the same time, dispatcher have to assign resources to these cases, and they have to optimize the resources because resources are limited. Here, our GraphAI solution essentially can help to detect on the fly duplicate incidences within our database, which allows in turn to optimize the resource management. Within the insurance domain, fraud is a common problem. People have to manually look at cases and understand based on from historical cases if this is fraud or not. Maybe there are hints, maybe there are pattern, but for a human this is for sure a huge effort and it is difficult. GraphAI can essentially help in such a setting to compare on the fly dynamically current cases with historical cases, to discover patterns which happened in the past in terms of fraud, and this helps in turn the human to quickly understand and scan a current case in terms of fraud. Research never stops, and AI is applied these days in more and more domains. For example, we have the digital government domain and the healthcare domain where the ethical aspect is very crucial. From our point of view as researchers, this essentially means we have to ensure that our algorithms ensure accountability, transparency, and explainability. So it's our duty to ensure that algorithms, that our AI algorithms, and so also GraphAI, keep up with the upcoming requirements.
Orchestrating a brighter world. NEC.